In this video, I will show you how to use trigonometric functions like sine, cosine, and tangent to solve a variety of problems. But first, you must memorize the three trigonometric functions, sine, cosine, and tangent. When you're dealing with a right triangle, you know the hypotenuse is across from the 90-degree angle, but then if you pick an angle, one of the legs is adjacent to that angle, meaning right next to, and one of the legs is opposite the angle, meaning across from. And the sine of the angle is the opposite leg over the hypotenuse. The cosine of the angle is the adjacent leg over the hypotenuse, and the tangent of that angle is equal to the opposite leg over the adjacent leg. Sometimes we use this funny word, SOHCAHTOA, to help us remember these three formulas. I've circled the parts of the word because the SO part means sine is opposite over hypotenuse. The CH part, cosine, adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So if you find it hard to remember all of this, SOHCAHTOA may be your best friend. Okay, problem number 1. The maximum safe angle of elevation for a fire department's rescue ladder is 72 degrees. If a fire department's longest ladder is 110 feet, what is the maximum height from which the fire department can safely rescue someone? So you need to draw some type of a picture of the situation. So let's see what we can do. Alright, here's my drawing of the situation. We've got a 110-foot ladder. So I'm going to put my 110 right here. It says that the maximum angle is 72 degrees. So that means this angle right here is going to be 72 degrees. We are supposed to be finding the maximum height that can be reached. So that's going to be this distance right here that we're trying to find. That's what we're looking for. So I'm going to go ahead and call that x. So the first thing we're going to do is pick an angle. Okay, so obviously we're going to pick the angle that we have labeled right here. So now that we have the angle, we will label the sides of this triangle. This is the hypotenuse, because it is across from the 90-degree angle. The side that is across from the angle is the opposite leg, and the side that's right next to the angle is the adjacent leg. So now we have to decide whether we're going to pick sine, cosine, or tangent, SOHCAH or TOA. Well, let's decide which one of these sides is not useful. Well, we have the 110, that's useful. We have the x, that's what we're trying to find. The one that we're not going to use is the adjacent side. So we have the choice between using SOHCAH, TOA. Alright, that's sine, cosine, or tangent. Look at the side that we're not using, the adjacent side. Since we're not using the adjacent side, then we are not going to use cosine or tangent. See, they both have the adjacent side in there. So that leaves sine. So sine of 72 is equal to opposite over hypotenuse. So that's going to be x over 110. When the variable is in the top, that is when you multiply. So we're going to multiply both sides by 110. And then these cancel out, and we'll just put this in the calculator, and that will be the answer. So we'll just type 110 sine 72. Okay, so that's 104.616. So that will be the answer to problem number 1. Problem number 2. The flag of Scotland consists of 2 diagonal white lines on a blue background. For a flag that is 3.8 feet across and 2 feet high, find the angles marked X and Y. Use what you know about trig and about rectangles. So they said the flag is 3.8 feet across and 2 feet high. None of these are right triangles. We need to find X and Y. So we can use symmetry. I'm going to need a right triangle so I can do tangent, sine, and cosine. I can get my SOHCAHTOA on. So how about if we were to split this triangle down the middle? So that's going to form a right triangle over here that I can work with. Okay, now this angle up at the top is not Y anymore because Y is double wide. So I'm going to call this something else. I'm going to call this angle theta. And if I find angle theta, I'm going to have to double it, and then that should be angle Y. Alright, but angle X is perfect just the way it is. So let's see if I can label some of the sides of this triangle. Well, if this side of the flag is 2 feet, can you see that this side of the triangle is half of the flag? Alright, this is right to the middle of the flag. So if the whole flag is 2 feet high, then up to the middle of the flag should be 1 foot high. So this side of the triangle is 1 foot. Similarly, this bottom side of the triangle is half of the flag as well. So if I do 3.8 divided by 2, alright, that is 1.9. So that tells me that the bottom leg of this triangle is 1.9 feet. Okay, so this is a triangle that I can work with. So it's time to do what we always do. Let's start by picking an angle. We are not given either one of these angles. So I'm just going to pick X because that's one of the angles that we are supposed to find. Now, once I pick an angle, I can label the sides. Always start with the hypotenuse, which is going to be across from the 90-degree angle. So that tells me that the hypotenuse is right here. Okay, now across from the angle is going to be the opposite leg. So this will be the opposite leg over there. Now, right next to the angle is the adjacent leg. So this is going to be the adjacent leg right here. So I have to decide between SOHCAHTOA. SOHCAHTOA. Okay? I'm trying to decide between sine, cosine, and tangent. So which one of these 3 sides is not going to be useful to me right now? I need to cross it out. Well, the opposite side is looking good because that's 1 foot. The adjacent side is looking good. That's 1.9. I don't know why I'm missing the T there, but I know both of those sides. The side that is useless is the hypotenuse. I'm not looking for it and I don't know it. So that's not going to help me. So I'm going to throw out the 2 options that involve that useless hypotenuse. Alright, sine and cosine. See how they both have the H in there? They are useless. I'm going to choose tangent. Alright, tangent is opposite over adjacent. So I have picked my angle. So I will say tangent of the angle that I've chosen is equal to opposite over adjacent. So that's going to be 1 foot over 1.9 feet. So I'm just going to say 1 over 1.9. So when the angle is inside the trig function, this is when we have to use the inverse trig function. So x will equal the inverse tangent of 1 over 1.9. And we can just put this in our calculator and we are good. Okay, for inverse tangent we hit second tangent 1 over 1.9. That is 22.759 degrees. Got to round up. Okay, so that is one of the things that we were supposed to find. Alright, we were supposed to find x. Now we are also supposed to find angle y. In order to find angle y, first we have to find angle theta. Now these two angles are complementary angles. Alright, they both live inside this right triangle. They are both the acute angles. They have to add up to 90 degrees. So if I want to find the other angle, all I have to do is subtract the first angle from 90. Okay, so if I want to find angle theta, all I have to do is take 90 and subtract the 27.759, and that will give me angle theta. Alright, so 90 minus 27.759, and that's 62.241. Okay, now remember angle theta is half of angle y. So if I want angle y, I'm going to have to double this. Alright, I feel like I should change colors when I change variables. I'll go to green. So angle y should be twice the size of angle theta. Okay, so I'm just going to take this value and multiply it by 2. So I'm just going to hit times 2. 124.482. And those are the two things that we were supposed to find. Angle x and angle y. Problem number 3a. This roofing truss is 24 feet wide, as you can see. The angle of the truss is 27 degrees, as you can see marked here. How tall is the truss? So the height of the truss would be like this, right down the middle. Let's see. Okay, this would be the height of the truss. And that is what we were supposed to find. I'm going to label that with an X because that is what we are supposed to find. So now I have my right triangle happening. Before I get too carried away, this right triangle, the 24 is not the bottom of this triangle, is it? So let's be careful. So I really need to focus on the right triangle. So of course the 24 is the whole truss. So 12 is going to be what's useful to me now in terms of solving this triangle. So now I can get back to the important work of solving this triangle for x. So let's do what we always do. Circle an angle. Now that I have an angle, I can label the sides. start with the hypotenuse. The hypotenuse is always across from the 90-degree angle. So here is the hypotenuse right there. Now, back to that angle. Across from the angle is always going to be the opposite leg. Right next to the angle is the adjacent leg. Now it's time to decide which trig function are we going to use. To help us remember the formulas, we will write down the word SOHCAHTOA. Alright, which reminds us of the formula for sine, cosine, and tangent. So, which one of these sides, opposite, adjacent, or hypotenuse, is useless to me right now? Well, the adjacent side is length 12. That's useful. The opposite side is the x that I'm trying to find. Got to keep that. The hypotenuse has got absolutely nothing going on. We don't know what it is, and we don't want to know what it is. Forget about it. So, see how the sine formula and the cosine formula both involve that worthless, useless hypotenuse. We're going to throw those out. And that leaves TOA, tangent. Tangent is opposite over adjacent. So that's the one we're going to wind up using. So let's go. We will say tangent of the angle that we circled, which is 27, is equal to opposite over adjacent. So that's x over 12. When the variable is in the top, that is when you multiply by the denominator. So we will multiply both sides by 12, and that will give us the answer. So we can just put this in our calculator. 12 tangent 27. 6.114. So that's it. That is the height of the truss that we were looking for. And we should say feet, because units. What if the truss must be 8 feet tall, and assuming it's still 24 feet wide? What should the angle of elevation be instead of 27 if we want the truss to be 8 feet tall? So here's a nice picture of what's happening now. So it's still, the truss is still 24 feet across, but now the height has got to be 8 feet. So here's the height right here. This angle that we used to know was 27. Suddenly, this is the thing that we are supposed to find. So I'm going to put an X there. Alright, and we do have our right triangle ready to go. So let's do what we do. Let's choose an angle. Of course, we're going to choose this one because that's what we are trying to find. Now we are ready to label. Start with the hypotenuse. The hypotenuse is always across from the right angle. So this is the hypotenuse. Alright, next we will label opposite and adjacent. Across from the angle that we just circled will always be the opposite leg. Right next to the angle is always going to be the adjacent leg. Now we have a decision to make. And that decision's name is SOHCAHTOA. Are we going to use sine, cosine, or tangent? And of course, SOHCAHTOA is reminding us of these three definitions. To help us decide which one of the sides is not helping us. Well, the adjacent leg is helping us because that's something that we know, 12 feet. I like the opposite leg because that's something that we know, 8 feet. The hypotenuse is not helping us at all. We don't know what it is, and it's not one of the things that we're looking for. It's useless. So notice how the sine function and the cosine function both involve the hypotenuse. Throw them out. Useless. Garbage. Alright? The formula that involves the things that are useful is going to be the tangent function this time. So we will use the tangent function, and we will write the tangent of the angle that we circled, even when that angle is unknown. That's what goes inside the trig function. So tangent of the angle is equal to opposite over adjacent. That's what TOA tells us. So that's going to be 8 over 12. When the variable is inside the trig function, that's when you need the inverse trig function. So we will solve this by doing the inverse tangent of 8 over 12. So second tangent of 8 over 12. $33.690 degrees. Alright, that's what this angle needs to be for the truss to be 8 feet tall. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.